All right, we are going to be talking about using properties of exponents. All right. Um, First, you need to know that all bases have to be the same. If they're not the same, you cannot use these properties. What I mean by bases, for example, if we have 5 squared, 5 is your base, and the 2 is your exponent. All right? So you must have the bases to be the same in order for you to use these properties. All right, so let's look at the first property. First property is product of powers. So for example, we have 4 squared times 4 to the 4th. All right, you notice I'm multiplying. The bases are the same, so since they are the same, I keep the base. Now I can add the exponents. All right, so if the bases are the same and you're multiplying the bases, you can add their exponents. So therefore I get 4 to the 6. And you just leave it like that. Now if I want to actually know what the actual value of that, then I can use a calculator if I need to. All right, the next property is called the power of a power property. For example, if I had 2 squaring it, then I'm squaring the whole thing. So 2 squared cubed. All right, so what that states is really what it means is this: 2 squared times 2 squared times 2 squared. 1, 2, 3. That gives me the 3. So really, now it becomes a product again, and all the bases are the same, so I keep the base and I can add the exponents. So therefore I get 2 to the 6. Now there's another way of doing this. All right? Instead of doing all this work, you can just keep the base, and you can just multiply the exponents. So it'll be 2 times 3. So it'll be 2 to the 6. The next property is the power of a product. All right, so for example, let's see, I have 2 times 5, the whole thing being cubed. Okay. What this means is, since this whole thing inside the parentheses, everything is being multiplied or divided. In other words, there's only one term inside. Right? So that means I can distribute my exponent. So I can do 2 cubed times 5 cubed. Right? Now, can I add these exponents? No, because the bases are not the same. So therefore, I can just leave it as 2 cubed times 5 cubed. And again, you can use a calculator if we need a value for it. Negative exponent. So I have some base, 8 to the negative 1. Here's a negative exponent. What that means is, take the reciprocal, 1 over 8. Right? Example, another one. Let's do 2 to the negative 5.
Coach Russo, call extension 2666. Coach Russo, call extension 2666.
Coach Russo, make sure you call extension 2666. Thank you. All right. So 2 to the negative 5, same thing as 1 over 2 to the 5th. In other words, the base and the exponents moves. Right? It's just that once you move it, it becomes a positive exponent. All right? So the negative exponent tells me to move my base and the exponent. Let's look at another way. Let's say we have, let's see here, 1 over 3 to the negative 2. Well, that means I can move this to 3 positive 2. In other words, 3 squared over 1. Right, so if it's on the bottom, it moves to the top. If it's at the top, it moves to the bottom. Next property, the zero exponent, which is probably the easiest one there is. It states that anything, any base, so for example, 10 to the 0 power is equal to 1. Right? 10,000 to the 0 power is 1. So anything to the 0 exponent is 1. The next property is called the quotient of powers. So for example, if I had 3 squared over 3 to the 15th, you notice here the bases are the same. So since the bases are same, I write the base. Now I can subtract the exponents. So 2 the top minus the exponent from the bottom. So therefore, 2 minus 15 is negative 13. You cannot have a negative exponent, so we got to take this further. Now remember, negative exponent tells me to move it, or flip it, or take the reciprocal of it, whatever you want to call it. So it becomes 1 over 3 to the 13th. Let's look at another example. Let's do 5 to the 20th over 5 to the 4th. All right, can I divide this two? Yes, because the bases are the same, so therefore I keep the base, subtract the exponent. So subtract the top minus the bottom. So therefore it's 5 to the 16th. And again, you can leave your answer like that. Now if the bases are not the same, then you just have to leave it the way it is. And then the last property is the power of a quotient. It's very similar to the power of a product, but instead of being multiplication here, it's division. So for example, if I have 2 cubed divided by 5 cubed. Okay. That's the same thing as saying 2 over 5th, all of it to the 3rd power. Because since the all right, let's look at one more example. Let's see, let's do 4 fifths to the 8th. All right, so again, there's all division inside, so therefore I can distribute the exponents. So it'll be 4 to the 8th over 5 to the 8th. And then you just leave your answer like that.